Hello. Now we're going to talk about finding domain and the different ways that we can find domain. Now, in order to do this, we need to know what domain is. So, domain is defined as the set of possible X, or rather input values. So, the set of all the values that we are allowed to plug in to a function. Now, there are different ways that we can find domain, but we're going to start by focusing on finding domain algebraically. Now, as I've said, domain is the set of values that we are allowed to plug in. So rather than trying to figure out the vast number of values that we are allowed to plug in, one thing we do is we say, well, what numbers are we not allowed to plug in? Because a lot of the time that is a much smaller set. So if we can determine which numbers that we are not allowed to use, then we can determine what our set of numbers would be. So we have two important factors, and in the start of this class, we really only have two rules we use when we're thinking about domain, but as the semester moves along, we're going to add a third domain rule. Right now, we have two important factors to consider though. The first one is, do we have a variable in the denominator? And why is this important? This is important because the denominator cannot equal 0. We are not allowed to divide by 0. So that's one of the things that we look at when we're thinking about domain. The other thing that we consider is, does the function that we're looking at have an even indexed root? And by saying an even indexed root, that means a square root or a fourth root or a sixth root. If I had a fifth root, that would be an odd indexed root. So does the function have a variable under an even root? And why is this important? This is important because we cannot take the even root of any value which is less than 0. So it can't have a negative under the radical. So whatever is under our even indexed root cannot be negative. It must be a positive number. And the way we say that in math, if it's greater than or equal to 0. And thinking about it, can you take the square root of 0? Well, 0 squared is 0. So then it stands to reason that the square root of 0 would be 0. Okay, so we have two conditions we are looking at. Do we have a variable in the denominator, or do we have a variable under an even root? And if neither of these cases exists, then there is no restriction. And if there's no restriction, that means the domain will be stated as all real numbers. And in this class, the way we state all real numbers is to say that my X values are in the set from negative infinity to positive infinity. So now that we know our two important rules that we need to consider, let's talk about how we would find the domain. Well, if there is a variable living in the denominator, the bottom of a fraction, then what we need to do is we need to take whatever that expression is, which is in the denominator, we set it equal to 0, and then we can solve to find the values we need to omit. The other way we deal with this is if we have a variable under an even root. Well, that means that expression under the radical, or the radicand, that expression under the radical needs to be greater than or equal to 0. And so then we'll solve this. That lets us know which values we need to restrict. So there's only two rules. Until we get to the end of the semester, if I ask you a domain question, you only need to consider these two factors. Now, we could have both of these factors occurring simultaneously. So what do we do if there is a variable under that even root, which is also in the denominator? That would mean whatever expression we had under the even root would need to be greater than or equal to 0. And, notice I'm saying and, that means both of these have to be true. And the denominator would not be allowed to equal 0. So I have one that says we can and one that says we can't, and we can't be both of those at the same time. So in this situation, we would say that expression would have to be strictly greater than 0. So this is just the intersection of our two other rules. When we look at both of the rules having to be true simultaneously, we end up with a greater than 0. Again, though, you really only have two rules. We're looking for a denominator because the denominator is not allowed to equal 0. And then the expression under the radical must be positive or equal to 0. So let's look at some examples. We're going to be given some functions and we're going to state the domain using interval notation. For my first example, A, we have f of x equals 1/2 x minus 5. Now we have two questions we ask ourselves when we're trying to determine domain. Does the function have a variable in the denominator? So you may notice we have a fraction, we have a denominator here, but is x in the denominator? And it's not. It's 1/2 times x. So that would be no variable in the denominator. And do we have an even indexed root or radical? Again, the answer is no. And we said if we answered no to both questions, that means the domain is all real numbers. We write that in interval notation and we say -infinity to +infinity. You may have seen kind of an R symbol that looks like this in the past. That's okay if you know what that means, but I'm going to expect on every test when you want to indicate all real numbers that you use -infinity to +infinity. All right, let's look at another example. Here we have g of x equals the absolute value of the quantity x plus 4. Again, we ask the question, do we have a variable in the denominator? The answer is no. Do we have a variable under an even indexed root? And the answer is no. Again, if the answer to both of these questions is no, that means the domain is the set of all x numbers that lie between -infinity and +infinity, or rather all real numbers. Example C, h of x equals the cube root of 5x plus 9 minus 2. So again, we ask ourselves that same question. We come back to the fact, do we have a denominator? Do we have an even root? Denominator, we do not have. Even root. Oh, do we? This is an odd indexed root. This is an odd index here. This is a cube root. 3 is an odd number. We do not have an even root. Therefore, the domain for an example, a cube root, would be -infinity to +infinity. All real numbers. All right, let's look at another example. Example D. Let's find the domain of the function j of x, which is equal to the 4th root of 3x minus 2. Again, we run through our two questions. Do we have a denominator? And the answer is no. And do we have an even indexed radical or root? And in this situation, the answer is yes, we do. That means the radicand, or the expression under the radical, must be greater than or equal to 0. So we say 3x minus 2 must be greater than or equal to 0. So let's look at solving for x. That would be 3x is greater than or equal to +2, or x is greater than or equal to 3/2. So as long as x is greater than or equal to 3/2, I will have a number that makes this a true statement or makes the value under the radical greater than or equal to 0. So To write that in interval notation, if x is greater than or equal to 3/2, that means we are going from 3/2 to positive infinity. We can be equal to 3/2, but we cannot touch infinity, so we must use a parenthesis there. All right, example E. K of x equals 7 minus x under the square root. So I have the square root of 7 minus x. So I look at this, and this is a even indexed root. When there's no value written, we assume there's a little invisible 2 there. This is the square root. So that means 7 minus x must be greater than or equal to 0. Negative x is greater than or equal to -7. We'll divide by a negative on both sides. That gives me x is less than or equal to 7. Remember, when you're dividing on both sides by a negative, that inequality symbol is going to flip directions. Another way you could have thought about solving this, 7 minus x greater than or equal to 0, just move the x over. That gives me 7 is greater than or equal to x. And rather than having to flip just the inequality sign, we can flip the entire inequality. And that's the same as x is less than or equal to 7. You'll notice these are the same values here. So if x is less than or equal to 7, the way we would write our answer, less than means we are going from negative infinity to 7. That would be our final answer. One thing that I might expect, or a mistake I might expect to see a student make, would be to write, well, this is from 7 to negative infinity. And remember, we said that intervals, we always have to go least to greatest, left to right. 7 is bigger than negative infinity, so that would be incorrect. Example F. We are given the function L of x equals x plus 5 divided by x minus 3. So, do we have a denominator? And the answer is yes, we do. Do we have an even root? In this situation, we do not. So we only have one thing to consider. So we have a denominator. I don't care what's going on in the numerator for a domain. I only care about the denominator. And what do we know about the denominator? We know that the denominator cannot equal 0. That means x minus 3 cannot equal 0, or rather x cannot equal 3. So if x cannot equal 3, the way we write that in interval notation is we say negative infinity to 3, x is less than 3, union, or 3 to infinity, x is greater than 3. So x is less than 3 or x is greater than 3. All right, let's look at another example. Example G. The function m of x equals 1 divided by the square root of x plus 6. All right, so let's ask our two questions. Do we have a denominator? And do we have an even indexed root? The answer to both of these questions is yes. All right, so what does that mean? So we know that the denominator is not allowed to equal 0. So that means the entire expression in the denominator, the square root of x plus 6, cannot equal 0. And for the even root, that expression, my radicand under my even root, that has to be greater than or equal to 0. So that means x plus 6 must be greater than or equal to 0. And both of these statements must be true. All right, so this is an and situation. They both have to be true. We have to look at where these two solution sets or intervals are going to be overlapping. All right, so solving over here on the left, let's square both sides of this equation. X plus 6 cannot equal, that would be 0 squared is still 0. minus the 6, x cannot equal negative 6. And then for my other equation, I would just subtract 6. That's x is greater than or equal to negative 6. So if x is greater than or equal to negative 6 and it cannot equal 6, right, here's my negative 6. So greater than or equal to looks like that. Strictly greater than is right beside it, but just a little bit above, a little bit past, right? So we see that little gap. So in this situation, x is in the set from negative 6, not including negative 6, to positive infinity. All right, I have one more kind of synthesis example for us. For example H, we have the function n of x equals the fourth root of the quantity 8 plus x divided by x. All right, so let's ask our two questions. Do we have a variable in the denominator? Yes. Do we have an even indexed root? Yes, we have both of these. So both of these situations that we're going to solve, they have to be true at the same time. So for an even indexed root, that means my radicand, the expression under the radical, 8 plus x has to be greater than or equal to 0. Solving that, I get that x is greater than or equal to negative 8. And my denominator is not allowed to equal 0, so that's just x does not equal 0. At this point, I have two inequalities, and I need to see where they overlap. Again, this is where I think graphing it on the number line can help you. So negative 8 is less than 0. I'll draw that on the left. X must be greater than or equal to, bracket, greater goes to the right. So greater than negative 8. And x cannot equal 0. Not equal to 0 means we are either less than 0 to the left or greater than 0 to the right. So now we are looking, and we have to answer where the red and the blue are occurring simultaneously. So from the interval negative infinity to negative 8, we do not have red and blue occurring simultaneously. On the interval from negative 8 to 0, we do. Not at 0, we leave that out, and then we have 0 to positive infinity. So my solution set here is that x is in the interval from negative 8 included to 0, not included, union 0 to positive infinity, and that's an open interval. So I hope that helps you understand domain. Really, it's two rules every single time you're asked. Is there a variable in the denominator, or is there an expression with a variable underneath an even indexed root? As always, please email me if you have any questions or concerns. This is a super important skill, and it is going to relay for the rest of the semester. All right, good luck out there.